Alright, definition 5.5 gives us the definition of a definite integral. All the integrals we've been looking at thus far have been indefinite, which means that we've been adding a constant of integration. But with a definite integral, we are given definite bounds. We have an upper bound, b, and we have a lower bound, a. Okay, so this is called the lower, and b is the upper. And we take the integral exactly the same way, but then we'll actually plug in these specific values in. And when you do that, when you plug those values in, you actually get the area under the curve y equals f of x from A to B. So you get the area of this red shaded region. Okay? And so that's the only difference. We're going to integrate the exact same way, but we'll actually plug in some bounds and we'll get something meaningful out of it to give us the area under the curve. So in this first example, we have y equals 3x, which would be a line that goes through 1, 3, and 2, 6. And it goes through the origin, so that'd be like y equals 3x right there. And what we're going to find is we're going to find the area from 0 up to 2 underneath that curve. Okay, and to do that we take the definite integral from 0 to 2 of 3x dx, and maybe I'll highlight the bounds in colors. So 0 is blue, 2 is red. Alright, so the first thing we're going to do is we're going to integrate that, and if it was an indefinite integral, you would say the integral is 3x squared over 2 plus c. But since this is a definite integral, we don't actually have to put the plus c, but we do have to record the fact that we have bounds. So in this first step, I always just write 3x squared over 2, and then I put the bounds next to like a vertical line right there to remind me that I need to plug those in. And that's fairly standard notation. Now what this is telling us to do is it's telling us to write 3 times something squared over 2 twice and to take the difference. Okay, so the first time that you do this, you want to plug in your upper bound, and the second time you want to plug in your lower bound. And it's really important to remember that you want to subtract off the whole function. So sometimes I put parentheses around my 2 copies. Okay. Now you just do the algebra. 3 times 2 squared is 4, so that's 12 over 2 is 6. So we have 6 minus 3 times 0 is going to be 0, so it's 6 minus 0, or 6. Okay, so that's telling us that the area is the integral from 0 to 2 of 3x dx. The area of that red region is 6. And now you can kind of check this geometrically. You know that this is a triangle with base 2 and height 6, and so that's half of this. That would be half the area of the rectangular region from side length 2 and side length 6, which would have area 12. So since we're taking half that area, it's exactly 6. So again, this area is equal to 6. The calculus tells us that, the geometry tells us that, both definitions agree.